In this lesson, we'll learn about rates, which are often used to measure change over time. A rate is composed of two parts, the quantity and the units. Most typically, a rate is a quantity of one thing considered in relation to one unit of another thing. Examples include kilometers per hour, miles per hour, calories per meal, and students per class. The word per means to divide by. A rate is created by dividing two quantities with different units. If we divide by quantities with the same unit, the units cancel out. In most problems involving rates, we use rates as conversion factors. Conversion factors convert one unit to another. For example, there are 100 centimeters equal to every 1 meter. This is a simple conversion factor. With this conversion factor of 100 to 1, we know that 300 centimeters equals 3 meters. Rates with different types of units can be used as conversion factors too. For example, gallons and minutes are two different types of units, one for volume and one for time. But we can use 500 gallons per minute as a conversion factor too. Rates can be used to solve algebraic questions and are typically used to manipulate units. Before we start some sample problems, remember any single quantity can be written over 1 to make it easier to do the math. For example, 60 minutes can be written as 60 over 1. This kind of thing is very useful when solving problems with rates. In this simple problem, we need to know how long it takes a driver to drive 700 miles when he travels at an average speed of 65 miles per hour. To solve, simply use the principles of algebra to get an answer that makes sense and contains the units you're looking for. In this problem, we know the answer we're looking for is going to be in hours, so we want to cancel out all the units except hours. To do that, we write our given rate, 65 miles per hour, as 1 hour per 65 miles, and we multiply it by 700 miles over 1 to make it easier to visualize. Miles cancel out, and we're left with 700 divided by 65 hours, or about 10.8 hours. In this example, we notice right away our answer is going to be in square meters, so we need to cancel out the other units so we are left with square meters. The rate we are given is 1 meter per 3.28 feet, and the minimum amount of space is 1,200 square feet. So we need to convert square feet to square meters, so we see what the minimum amount of space need is in square meters. The trick here is that although 1 meter is about 3.28 feet, 1 square meter is not about 3.28 square meters. What we actually have to do is multiply our original value in square feet by the conversion factor twice in order to cancel out the feet squared. So we put 1,200 square feet over 1 and multiply it by 1 meter over 3.28 square feet, and then we repeat. Square feet cancel out, and we're left with 111.5 meters squared.